When the slides come on, they'll be visible.
S.S.Bhandari, S.S.Bhandari, Shivani Sethia.
Want to see the slides? Of course, keep the social distance anyway. Between the two or you also. Hello.
Hello.
Ji, Bhandari sir. Sir Bhandari, how are you?
Namaste. Namaste. Welcome.
Bhandari sir.
Go ahead, please.
Very good evening. Jaipur Citizen Forum is proud to welcome our most distinguished, most respectable, known all over the globe, one of the greatest scientists of all time, and working for last 5 decades, Padma Vibhushan, Dr. R.Chidambaram. Along with him, we also welcome our 2 panelists, Major General Anuj Mathur and FCA Shri S.S.Bhandari, and also our JCF family and guests in the talk show for our talk show HUM 10. Sir, Jaipur Citizen Forum is a platform which promotes local art and culture along with organizing cultural events with various artists, speakers, etc. To name a few, we co-hosted A.R. Rahman's concert in Jaipur, played by Paresh Rawal, played by Anuj Govind, a show by Gujrat Sahab. In these Corona times, we came up with a new set of series, Hum Tum, wherein we organize webinars, talk shows with some of the culturally very strong individuals, influencers of the country, globally, for the citizens of Jaipur who are part of JCF. Till now, we have had the pleasure of having 9 such webinars led by the following. We had the privilege of having Hema Malini ji and Mrs. Isha Dayal, Mr. Anand Sharma, former Cabinet Minister for Commerce, Mr. Raghavendra Singh Rathore, famous designer, Mr. Amish Tripathi, famous writer, Mr. Rajiv Arora, our CMD Amrapali Jewels, Dr. Sunil Shroff, famous transplant surgeon, Prasoon Pandey, famous director advertisement, Mr. Govinda, famous film star, Mr. Shashi Tharoor, politician and writer. JCF body boasts of 370 culturally strong families of Jaipur, which is being led by Mr. Rajiv Arora as chairman, Mrs. Jayashree Pediwal as co-chairman, Mr. Ajay Data as secretary, Mrs. Bhavna Jagwani as joint secretary, Mr. Anil Bakshi as treasurer, and Mr. S.S.Bhandari as advisor, and myself, J.K.Jajoo, convener programs. Sir, JCF is also involved in cadaver organ donation along with Mohan Foundation. We have been supporting organ donation for last 5 years, making a difference in almost 130 lives. That means we have done 130 live organ donations. Also during the time of uncertainties like COVID-19, JCF has always come forward for the support of citizens of Jaipur. During lockdown, JCF took the initiative of supporting doctors, paramedical staff and patients of COVID-19 in SMS Medical College and Hospital and Jaipuria Hospital. And even now we are lending our hand of support to RUDP Hospital where COVID-19 patients are still admitted. We used to get the information of hospital requirements and accordingly we supplied during the period almost 1 lakh bottle of water, thousands of coffee and tea and biscuits and muffins and fruits and food packets to these doctors, paramedical staff and patients of almost 1400 in numbers. Also, we supplied food to almost 25,000 people during this period. Sir, once again, a very warm welcome. And now I would request our Jaipur Citizen Forum Chairman, Mr. Rajiv Arora, to please come and tell us more about Padma Vibhushan Dr. Chidambaram. Please, Rajiv ji. Sir, unmute. Please unmute yourself.
Yeah, I have done. Thank you. Thank you, Jajoo Sahab. And welcome, Dr. Chidambaram. We are so privileged you are here with us. Before introducing you, I would like to introduce the panel, the moderators, and especially Shri S.S.Bhandari, who is instrumental asking you, requesting you, and we are really thankful that you accepted our invitation. So Mr. S.S.Bhandari is a qualified chartered accountant. He's a founder partner of Messrs. S. Bhandari and Company in Jaipur since 1971. And his firm is one of the most renowned firm of chartered accountants in Rajasthan. Mr. Bhandari was also director, Central Bank of India, RBI nominee on Erstwhile Bank of Rajasthan, chairman and board of trustee of PNB Mutual Fund, and director Bank of Baroda. Very illustrious career. He was also in many other important institutions, and presently he is director with Asian Hotels. He is member Finance Committee of Indian Institute of Technology, Jodhpur. He is chairman Finance and Audit Committee, IHMR, Jaipur. He is also founder and trustee with me in Jaipur Citizen Forum. This is a leading NGO promoting art, culture, heritage, organ donation, and different projects of social importance. He is also very actively working with Bhagwan Mahavir Viklang Sahitya Samiti, which also work for artificial limb, the famous Jaipur food. And it is one of the largest NGO who is working for handicaps in the world. And he's deeply involved in various social and philanthropic activities. I welcome Shri S.S.Bhandari. And also the second moderator today is, we are very proud, a Jaipur boy who became general in army, Major General Anuj Mathur, VSM, and an alumni of National Defence Academy. He is a graduate of Defence Service Staff College, Wellington, and has done his MSc in Strategic Sciences from University of Madras and LLB academic from MLS University, Udaipur. He has also written and presented papers at various fora. He commanded his unit in the Kashmir Valley during Operation Parakram. He also commanded a brigade in the Western sector in JKRIF Training Center. He has also commanded an area and sub-area as a general officer. He has won a number of commendation during his illustrious career. Afterwards, after leaving his services, after his retirement, he is working as a motivational speaker and also involved in activities of spreading awareness about national security. He is a specialist in Kashmir and China issues, and he always gave talks. I was also listening in recently on TV channel, I think yesterday with this problem with China now on the border. And he is also very actively involved in social services, post his superannuation from the Great Indian Army. Now, the most important point, I'm really excited and privileged to introduce a person who has been a Dronacharya to many Eklavya around the nation, the mentor to nation's young generation. And of course, as we all know him, when India went nuclear in May 1974, he was there. In 1974, he was there. In May 98, when the country went back to Pokhran to test another bomb and declare itself a nuclear weapon escape, he was there at that time also. And we have seen a movie, Parmanu, the Pokhran, made on that 1998 explosion. And if I am correct, I don't know, in this particular time, for this nuclear explosion, he had a code name, Nataraj. I'm not sure whether it's right, but for my information, his name was Nataraj at that time. Smiling Buddha in Operation Shakti were among Shri R.Chidambaram's greatest achievements, as also being principal scientific advisor to the government of Prime Minister. He worked with Shri Atal Bihari Vajpayee. He worked with Shri Manmohan Singh and also Narendra Modi ji. Chidambaram ji, who hails from Tamil Nadu, joined bar in 1962 during the time of the legendary Homi Bhabha. Who doesn't know Homi Bhabha? At that time, he joined bar. He steadily rose to be part of the critical team that made the nuclear bomb and conducted the 74 Pokhran test in Rajasthan deserts. He headed the bar in the late 1980s. He also consequently became the chairman of Atomic Energy Commission. He was the first to introduce automation for data collection with neutron diffractometers. And he was also instrumental in introducing crystallographic computing in India. He initiated work on the design of nuclear explosives. He is the first one to work out the equation of state of plutonium. Dr. Chidambaram is a recipient of C.V. Raman Birth Century Award. He got Padma Vibhushan in 1999, which is one of the highest honors in our country, second highest to Bharat Ratna. Also, he got R.D. Birla Award of Indian Physics Association, Meghanand Saha Medal of INSA, Homi Bhabha Lifetime Achievement Award of Indian Nuclear Sciences, Lifetime Contribution Award from Indian National Academy of Engineering, and the Jawaharlal Nehru Visiting Fellowship of INSA. He is a fellow of the Indian Academy of Sciences, Bangalore, the National Academy of Science, India, Allahabad, the Indian National Academy of Engineering, Institute of Physics, London, and the Third World Academy of Sciences. It is a long list of awards and honors with our spending more time on this. I request Dr. Chidambaram, please start his presentation. You are most welcome and address the JCF members and our guests. Thank you.
Thank you. Thank you, Mr. Rajiv Arora. It's a pleasure to address the Jaipur Citizens Forum. And I'm grateful to Shri Bhandari and you, of course, as the chairman and other members of your forum. And from what I've heard just now, and of course I've heard a bit before also, the kind of things that you do are so impressive for society. Of course, art is also part of your activities, but particularly the kind of work which all of us must be doing during this COVID times, supporting the people who have been made helpless due to various reasons. So as I said before, it's a great pleasure to talk to you and your members at various parts of Rajasthan and maybe outside Rajasthan. Can I start? Are you able to see the slide, please?
Yeah.
Yes. I'm going to talk to you basically about India becoming a knowledge economy. So the first step is to become a developed country. And having done that, we want to become a knowledge economy with the ability to generate new knowledge and with the ability to appropriate knowledge generated in any part of the world for the benefit of our society, our industry, and of course our strategic needs. India of our dreams. The United Nations in 2015 defined 17 sustainable development goals. No poverty, no hunger, good health and well-being, affordable energy, and so on. Of course, they are all interlinked to some extent. But for us, that is only the beginning. As before, we want India to become a developed country and then a knowledge economy. All sustainable development goals of that United Nations defines can be compressed into one parameter, which is called the Human Development Index. Fortunately, the Human Development Index in India is at the moment not very high, but we want India to be, I'll show a slide on this a little later. I want India to be among, and I'm sure all of us want, within the top 10 countries of the world. Economically developed India, we want scientifically advanced India with excellence in basic research. And some years back in 2007, I defined a phrase called directed basic research. Still basic research, which is usually self-directed. You don't control, nobody controls it. You don't ask C.V. Raman or Srinivasa Ramanujam to prepare a project report which will be examined by me and Mr. Bhandari to decide we can fund it or not. The highest intellects in a country must be allowed to work on fundamental problems of their choice. But as the world has progressed, the basic research has a much broader meaning. But directed basic research is not directed by anybody, but basic research directed towards India's needs in the long term. India's industry needs, India's societal needs. Not applied research, still basic research, but directed towards India's needs. Then we should have excellence in applied research, technology development, R&D-led innovation. Of course, all these have no use unless we are backed. All these is backed by high-quality manufacturing skills. Choice of technologies, we need technology foresight. I'll define it in a moment. Select the critical technologies, the most important technologies for India's rapid development. But sometimes we forget India is a very large country and India's technology needs range from nuclear and space to rural. All this we should decide through technology foresight. And we want India to be militarily strong. The ability to fight and win conventional wars, crush perpetrators of low intensity conflicts, and with the capability for nuclear deterrence. Of course, we have all this now. In national development, national security, we want both. And in the Naidama lecture, which I gave in November 1999, I said that national development and national security are two sides of the same coin. Development without security is vulnerable. Security without development is, of course, meaningless. Technology foresight has been variously defined as some people consider prediction methodology for determining the most likely technological developments in the midterm future. But in my opinion, shared by many others, this is what we should really call technology forecasting. Technology foresight goes beyond that. You have to add to technology forecasting. What are the possible technologies which will be developed in the near future, midterm future, or even in the distant future? And add to it assessments based on our economic needs, our social needs, our environmental requirements, our security. So there are some issues like human cloning. You have to also to consider ethical points of view from a national perspective. And these technologies must be reassessed periodically because suddenly, for example, I remember Franklin Roosevelt, President of the United States, asking some of his senior scientists and engineers to tell him what will be the most important technologies in the next 25 years. They missed nuclear energy because nuclear fission was discovered the next year. They missed radar, they missed lasers, and they missed so many other things. So technology foresight assessments, analysis has to be done periodically. On this basis, the critical technologies for India today, I think, are strategic technologies, nuclear, space, defense, technologies related to energy security, health and water security, environmental security, agricultural food security, including genetically modified crops, gene-edited crops, low energy technologies, low carbon energy technologies, then advanced materials, manufacturing, supercomputers, cybersecurity, artificial intelligence, technologies for micro, small, and medium industries, and technology for sustainable rural development. I mentioned nuclear. You may like to hear the views of the Director General of the International Atomic Energy Agency, who gave a lecture in Bach. You see, India has developed, not that we have not developed, we have developed. Some areas we have developed more than in other areas. And in the case of nuclear, Yuki Amano says, and I quote, I would like to conclude by noting that India's remarkable success in the field of peaceful nuclear technology is an inspiration for many developing countries. I also appreciate India's willingness to serve as a mentor for other Asian countries that have recently joined the International Atomic Energy Agency. Of course, this is part of Indian culture. We have always been ready to help other countries who have needs for which we have the capability. India is at the forefront of technological development in the nuclear sector, not least in the area of fast reactors and related fuel cycles. Fast reactors and related fuel cycles will be important for the long-term sustainability of nuclear power. Of course, I was referring to the Indian three-stage nuclear power program. I'll briefly mention in my next slide. So our reactors are doing very well. On December 10, 2018, the indigenously built Unit 1 of the Kaiga pressurized heavy water reactor nuclear power station in Karnataka broke the world record for continuous operation, 941 days since May 13, 2016. If you feel like you can clap now. The audience can clap if you feel like. It had been held earlier by the Heinsham Advanced Gas-Cooled Reactor Nuclear Power Station of United Kingdom, 940 days, and we crossed that. Then, of course, when they reached 962 days, they decided, the regulatory board asked them to shut it down for maintenance. See, whether your car, whether it's your personal car, or whether it's a nuclear reactor, if it is reliable, it is safe. If things there are working properly or maintained it properly, then you are very unlikely to get into an accident. Same thing is true for a reactor. Safety and reliability go together. What it means is if we can break the world record, that means our reactors have a high degree of safety. Of course, this has been mentioned also by the IAEA when it came from an operational safety review mission. See, there is no field of nuclear, no field of societal endeavor in which nuclear is missing. It's not just electricity and nuclear weapons. We can produce new varieties by radiation mutants. We are able to export mangoes to the United States. It is because we can extend the shelf life by radiation. Radiation, sterilization of medical products, cancer treatment. If you want to know cancer treatment, cobalt-60 gamma radiation can kill cancer cells. And Bhabatron, which you see here, a picture in this Bhabatron, this was made by us and it has been sold at half the price what was available in the commercial market. And it's an extremely important tool for radiation treatment of cancer. There's a book by Nassim Nicholas Taleb called anti-fragile, things that gain from disorder. Anti-fragile. It's the same guy who defined the word black swan. Some of you might have read this book. Black swan is a swan. We expect the swan to be white. Black swan is an unexpected event with serious consequences. Same thing, he introduced the word anti-fragile. There are two kinds of things. Fragile are things which break down under stress. Robust are things which withstand stress. But anti-fragile are things which get stronger under stress. Like some of the microbes. Some of the microbes, the more you treat them in antibiotics, they become stronger. And I have always said that our nuclear program is anti-fragile. The more they try to control us by putting technology control regimes, we became stronger and more self-reliant. Not that I want technology denial for all time. Now that they know we are powerful enough, all those technology restrictions are removed. Nuclear supplier guard group guidelines have been relaxed for us as a very special case. Non-signatories, the NPT, this is what was restrictive. Of course, we had the help of the United States in this. Of course, we should further encourage international cooperation to strengthen our initiatives. Self-reliance does not mean we have to do everything ourselves. Critical things. That's why I say self-reliance does not mean trying to do everything yourself. If you are building a complex system, everybody else in the world does that. And if you want to get a subsystem which is available from a reliable source, no harm in putting it in to save time. But if anything is denied to you, including the proverbial wheel, then you should have the capability to do it yourself. This is what I defined. I defined it when I was director back a long time ago. Self-reliance has immunity against technology denial. And since we are growing, I used to tell my Western friends, we need you in the short term, you are going to need us in the long term. And it's not just for that, it is something which is going to happen. Mr. Rajiv Arora referred to Homi Bhabha, the founder of our nuclear program. And he was not only a great leader. See, some great leaders, after they disappear from the scene, the system begins to collapse. Not in the case of Bhabha, who died in a very tragic air accident. He created a leadership swarm around him. Homi Sekna, chemical engineering, Raja Ramanna, physics, Brahm Prakash, metallurgy, A.S. Rao, electronics. And then he established a culture in the Department of Atomic Energy. And that culture still remains, and which helped to nucleate so many more leaders in the next generations. There is a famous writer called Arthur Koestler. Some of you might have read his books. He has written a book called Management and Machiavelli. Machiavelli was the Italian Chanakya. And he defines two kinds of leaders, the yogi and the kamisa, the contemplative thinker and the man of action. Of course, all of us are a mixture of both. But Dr. Bhabha was a unique mixture. Could think very far, and then he could execute his plans. And he had great technology foresight. He thought of India building nuclear reactors at a time when we were not even building bicycles. That is technology foresight. Was coming to the nuclear explosive program. The father of the Indian nuclear explosive program was Dr. Raja Ramanna. He was director of the physics group at that time in BRC. In fact, he had brought me into the nuclear explosive design field in 1969. He says in his autobiography in 1991, just before the May 1974 test, there are some people who had objections. They said economy will collapse. Time was not ripe for the test. We were already there, and Ramana told Mrs. Indira Gandhi that now it is impossible to postpone the date given the expense, time, and the critical stage experiment has reached. Fortunately for my team, Ramana says, Mrs. Gandhi decreed the PNE, peaceful nuclear explosion experiment as it was called, should be carried out on schedule for the simple reason that India required such a demonstration. We called it the peaceful nuclear explosion because IAEA was going to for holding meetings every year from 1970 on peaceful nuclear explosions. This was the idea of President Eisenhower, US President, swords into plowshares. So we said it's a good idea. And what the first meeting I attended in 1971, Ramana had sent me there. I said we would like to mine copper underground by sending dilute sulfuric acid and taking out the copper values. This is a completely peaceful, and use the nuclear explosive to crack the rock, fracture the rock. And you can take the copper value out without bringing out the radioactivity. In fact, I and Dr. Ramana presented the result of the 74 PNE experiment, the IAEA in 1975 in Vienna. After 74, we kept the nuclear option open. That is the most difficult part between 74 and 98. Nobody had such a big gap between two series of tests or two sets of tests. And keeping the program going was a very difficult job. And of course, that we did. But that must be told, the development work was not stopped by any prime minister during that period. Then fortunately, as we all know, Prime Minister Bajpai came, Bajesh Mishra as his principal secretary, and we could carry it out the 5 May 98 tests. See, nuclear disarmament, nobody wants to fight with nuclear weapons. The damage is too much. And everybody wants nuclear disarmament. But they had a treaty for that, but it was a very unequal treaty that 5 countries who had done nuclear tests by an arbitrary date were called confirmed nuclear weapon states. And everybody else was prevented from carrying out any tests. Of course, India felt it is a very unfair treaty. We didn't agree to that. But there's a large number of signatories, and many joined, convinced that security concerns will be addressed by one or another state. They also thought one day global nuclear disarmament will come. Many people felt they will be sheltered under the so-called nuclear umbrella of the nuclear weapon states. But India's security concerns were left unaddressed. India exercised self-restraint for a long time, but had to finally weaponize the context of a sharply deteriorating security environment in East Europe. Of course, clearly, we all want nuclear disarmament, which means eliminating all nuclear weapons. But the whole question is, what is the probability of achieving nuclear disarmament in the context of mutual suspicions among inimical countries? When you reach near zero, how much trust will each one have that the last weapon has been destroyed? This is adapted from a paper speech I gave in Tokyo in 2001. It was published in 2001 in Current Science. This is a paper I published 2008. It's an international journal, Atoms for Peace. And I have given, of course, we can't give, nobody will give the designs. But I have mentioned that these tests were the culmination of an outstanding and committed team effort, both within BARC, and we had the collaboration of one lab in DRDO in Chandigarh, the Terminal Ballistics Research Lab, because they are experts in explosives. And when we had to make explosive lenses, they were the right people for that. Of course, the designs we did in BARC. but they were fabricated and tested. They have been our big partners. Now it is universally recognized that India's nuclear weapon development program is based on self-reliance. I'll show you the next slide, which is a Venn diagram given by Payne and Mackenzie immediately after our test. Of course, the Indian tests were fully successful in terms of achieving their scientific objectives, establishing the computer simulation capability to predict the yields of nuclear weapons. Fission weapon, we tested a 15 kiloton fission weapon, which was a boosted fission weapon. Boosted fission means first you produce neutrons using fission, then you add some thermonuclear material to increase the yield of it. For the CM yield, the size becomes smaller. And boosted fission is always the first stage of a thermonuclear device. Two-stage thermonuclear. And these weapons, fully tested, we also tested sub-kiloton weapons, that is less than 1 kiloton. And these were to prove the physical. We had put in a lot of physical calculations. And all our principles that we use tests perfectly verified by these sub-kiloton tests, what I call the chotus. They were extremely well there. It's a carefully planned series of tests I mentioned in that 2008 international paper carried out by us, gave us the capability to design confidently and build nuclear weapons from low yields up to around 200 kiloton. Greater deal of further scientific and technical development has taken place till then. You know, we restricted the yield to 45 kilotons. The shaft in which it was tested actually was dug during Rajiv Gandhi's time. Rajiv Gandhi's time, Dr. R.Chidambaram was there as chief of DRDO. We had dug the shafts, and for that depth, you know what happens when a nuclear explosion takes place? The area around, the volume around the nuclear explosive gets vaporized. Now we have a hot cavity of radioactive gases from which the shock wave proceeds outwards. As it proceeds, spherically diverging wave, it is no longer strong enough to vaporize the rock, but it melts the rock. Now we have a situation, a cavity of hot radioactive gases surrounded by molten rock. The good thing is all that molten rock drips to the bottom of the cavity and traps most of the radioactivity in vitreous rock. But as it proceeds outwards, it cracks the rock. There are a lot of fractures around the shot point. When the shock wave comes and hits the ground, what came as a compressive shock goes back as a rarefaction wave, and the ground goes up. And you are lifting ground which is brittle, it is a rock material, and that it cracks. And those cracks go downwards. If the cracks coming from the surface and the cracks around the shot point meet, then you have venting of radioactivity. And my colleague, Dr. Sikka, had made all these calculations, and we had knew the exact geology of Pokhran site where the test was conducted, thermonuclear test particularly. And we knew anything more than 45 kiloton may vent radioactivity. So that's why, but the design, by changing the composition of the isotopes, material, because that's what I have said here, can easily go up to 200 kiloton. We control the yield actually. This is the Venn diagram drawn by Payne and Mackenzie. If you are teaching our children or grandchildren, you know what a Venn diagram is. And in set theory, when two things intersect, there is a sharing between them. This Venn diagram is of sharing of nuclear weapon knowledge. UK and US have worked very closely together during the Manhattan tests and afterwards. Sharing of knowledge, US and France, France, US and Israel, Israel and South Africa, Russia and China, China and Pakistan. And you see where my India stands, alone. What they are saying is Indians did not steal any knowledge. They were not assisted, helped by anybody. And the entire program was based on self-reliance. Because I talked about fission energy. Fission energy, it's all based on E is equal to mc square. Good old Einstein's equation. When a neutron goes into uranium-235, it breaks up. Fission. Breaks into particles. The mass of the particles is less than the mass of the neutron plus the uranium-235 nucleus. That deficit is converted into energy. E is equal to that deficit mass multiplied by the square of the velocity of light. Similarly, if light isotopes of hydrogen, the deuterium and tritium, heavy isotopes, if they get together and they fuse, there is a mass deficit and you get fusion energy. What we call solar energy starts from the sun, fusion energy. Fusion is taking place in the sun. And that energy comes to us, we call it solar energy on the earth. And in order to bring isotopes of the hydrogen together, hydrogen has got 3 isotopes. Normally it's called H hydrogen, 1 proton, no nucleus, no neutron. P, 1 proton plus 1 neutron. Tritium, which is radioactive, 1 proton plus 2 neutrons. Is the proton is balanced by the electron around. The electron does the chemistry. So the chemistry is not very different between the various isotopes of hydrogen, but the nuclear properties are very different. When isotopes of hydrogen come together, they are positively charged particles, they repel each other. They don't like each other, so they stand away from each other. But if you heat this plasma, this heavy hydrogen plasma, DNT, or D and D to 50, 100 million degrees, 50, 100 million degrees centigrade, by sheer kinetic energy, they come near each other and fusion begins to take place. Fusion cross-section is a function of energy. And one of the best theoretical methods done at the lab scale to have a certain density of what we call the Lawson criterion and containment time, n tau, that is the Lawson criterion, and the temperature has to go up beyond 50, 100 million. No vessel can contain it, so it has to be contained by a magnetic field. The most popular method is a donut-shaped plasma. It's called the tokamak, which is a Russian term. And 500 megawatt tokamak is an international project. It's being built in France. It is called the ITER, International Thermonuclear Experimental Reactor. India is a member, and a major thing it is contributing is this cryostat. Of course, we are contributing other things, which is designed by the Institute of Plasma Research in Gandhinagar near Ahmedabad, as you all know. And this cryostat has got 2 parts, of course, one for liquid nitrogen, liquid helium. And this is the largest cryostat ever built in the world. 30 meters in diameter, 30 meters in height. This cross section that you see there. And this has been designed. And the base has been installed at the ITER in Cadarache, France, 26th, 27th May this year. Just last month. And of course, this is my inaugural address in the Fusion Energy Conference, which was held in Gandhinagar last year. And there I said, fusion science is a fascinating physics. It's a physicist's delight, but an engineer's nightmare. It was very difficult to bring. But they are hoping that ITER 500 megawatt reactor will come sometime during the late 2030s. Let me come to technology development. These are the 3 steps: research, development, delivery. If you take industrial development, academic institutions are good in research, companies are good in delivery, both are weak in development. And this is the part that has to be strengthened through academia industry interfaces. When I was a PSA, I brought together, it has to be technology specific. Each technology sector requires a different kind of interface. So we brought in for the automotive sector, core advisory group for automotive sector, which had members from both industry and academia, machine tool sector and so on. And this requires both directed basic research and what is called pre-competitive applied research. If a company wants to improve its products, it is a job of the company. That is proprietary applied research. But if there are generic problems, the government can do it, ask its academic institutions to do that. Of course, the company can interact with academic institutions and pay for that development. Of course, they can do that. But if you do that, the intellectual property rests with the government. This is beginning to happen in India in a large way. And of course, this is what we must strengthen if you want a self-reliant India, ability to develop the technology. Every sector, you must develop this academia industry interaction services. In the case of rural development, the problem more of delivery. Knowledge is there, not reaching rural areas. And what we have done, try to do this through RUTAG, Rural Technology Action Group, centered in 7 IITs, through knowledge transfer. There's a term called knowledge brokering. I will not go into that. Scaling of innovations, and what I call concept transfer followed by re-innovation. When we take up large projects, technology management, leadership can be done within an institution. Let me build nuclear power plant. Most big projects are multidisciplinary. You want me to build missiles, space launch vehicles, nuclear power plants. All these capabilities are usually within. Of course, they take the help of others, but the core competences are within an organization. But if we take a Pokhran test of 74 and 98, where DAE, DRDO, and the armed forces were involved, you require competencies from various organizations to be brought into synergy. एक शायरी बता दूं आपको कि अमर अकबर एंथनी में एक गाना आता है, अनहोनी को होनी कर दे, होनी को अनहोनी। एक जगह जब मिले हो तीनों, DAE, DRDO and the armed forces. Same thing we have done for the advanced ultra supercritical thermal plant, which I had started when I was the PSA. We brought Indira Gandhi Center for Atomic Research for materials, BHEL, who are the best equipment manufacturers, NTPC, who are the best utility, and so on. This is what I call synergy projects, which we have taken up a number of them in our rural development. This is RUTAG. And of course, as I said, centered in 7 IITs, but we take from other organizations also. In Uttarakhand, there was this water problem. Water in hilly areas runs downhill very fast. And they have a water shortage of rainy season. So to build on the top of the hill, what my friend Dr. Anil Joshi calls khals, water ponds. And that water seeps through broken rock and reaches the aquifers where the villages are located. This is how they recharge the aquifers. But Dr. Anil Joshi's problem was, how do I know when I build a khal that the water goes to the useful places and not run away to useless places? So we brought in this technique of isotope hydrology. These are stable isotopes, also tritium we have used. And the BRC used this technique, ratio of 18 oxygen, 16 oxygen, heavy hydrogen, normal hydrogen, presence of environmental tritium and all that. And said, what is trying to go this way? You see on the left slide, the subsurface, the white walls, these are the subsurface dikes which were built to divert the water to where the villages are located. And this has been extremely successful. And rate of discharge 3 to 9 times it has gone up. And it has made a lot of difference to the village. In fact, of course, one has to look at the geology, the mountains where this is located, very careful geology has to examine. But this is being replicated in many other places. You know, there is a very interesting book by Yuval Noah Harari, Homo Deus. He wrote a book called Homo Sapiens, and then he wrote a more recent book, Homo Deus, Man and God, Brief History of Tomorrow. And there he says, humans nowadays completely dominate the planet, not because the individual human is far smarter and more nimble-fingered than the individual chimp or wolf, but because Homo sapiens is the only species on Earth capable of cooperating flexibly in large numbers, unquote. And communication is the foundation on which the cooperation is based, like we are communicating with each other. And part of this communication is e-communication. And that is why in 2010, when I was the PSA, we introduced the idea of the Indian National Knowledge Network. This is now the largest global network, research and education network in the world, operated by the MIT, National Informatics Center. Director is Dr. R.S. Mani, and connects 1,600 plus institutions. This is what we call the backbone POPs and core POPs, and then connected to edge institutions. And this is working wonderfully. We are also connected to CERN grid, the European. CERN is the Center for European Nuclear Research in Geneva. When the God particle was discovered, Tata Institute of Fundamental Research was involved. And because of NKN and connection to the CERN grid, we could get the live data from the detectors directly to the Tata Institute of Fundamental Research. Of course, big data analytics is a big issue, and this is very useful for that. Artificial intelligence, now it is available all over the place, machine learning, big data analytics, every field from commerce to cyber security. Of course, we use it in nuclear. And you can make expert systems based on AI and ML, the decision support system, symptom-based intervention, guideline management, most importantly, false alarm suppression, and you can do prognostics. Coming to the end of my talk, this is my last slide. You know, the final analysis, technologies. Alvin Toffler, the famous futurologist, said a long time back, yesterday violence was power. Today wealth is power, and tomorrow knowledge will be power. Of course, he said many years back, knowledge is power, even today. You analyze it. Yesterday violence was power, today also violence is power. Whoever has the best technology for inflicting violence is the most powerful technology. Today wealth is power. Whoever has the best technology for creating wealth is powerful. Tomorrow knowledge will be power, which is already happening. Whoever has the technology to convert knowledge into value is powerful. What is common to all this technology? So I paraphrase Alvin Toffler to say technology is power. Because technology is power, there are two methods of controlling it: intellectual property rights and technology control regimes. And we have to counter this from India through technology leadership. And we should have the ambition to first introducer of new advanced technology. People are very careful. They say, let the technology be proven and then we'll adopt it. And I tell to them, the so-called proven technologies, unless of course they're subjected to continuous evolutionary improvements, the so-called proven technologies are often a synonym for obsolete technology. Certainly we don't want that. Thank you very much. I'm stopping here.
I request Bhandari Sahab and Anuj Mathur sir to please start the question answer session.
Yes, please.
Sir, thank you very, very much. It was a comprehensive and exceptionally good and well received talk by you, sir. I will slightly divert, and I'll take you to a smaller, more interesting issue. Besides being one of the best ever nuclear scientists this world has seen, you've also been in the topmost echelons of decision making as far as the creation the nuclear doctrine for the nation is concerned. And while doing so, no first use policy was the thing which you always favored, and you've been favoring. But
Good. I didn't follow.
taking a clue from what the RM made a statement last year that there is, this policy is not forever. Do you think there is a for us to go back on this? Is our nuclear doctrine of no first use policy adequate, or we need a change in it?
See, the no first use is there in our nuclear doctrine. If everybody says no first use, agrees to no first use, it's as good as nuclear disarmament. But it is a voluntary statement. What the defense minister, Raksha Mantri ji, said was, it is not a commitment, it's not a treaty commitment, it is only a voluntary policy statement in the nuclear doctrine. I'll leave it at that.
Thank you very much, sir. I think that would do. And I don't think there is a real need for us to go and revisit the policy as of now. The second issue that I thought I will have some views from you is, the world is worried about the terror, nuclear terrorism. Now, the terrorism is variety of kinds. As a soldier, I have experienced all kinds of terrorisms. But given the neighborhood that we have, what is happening then over there, and a possible availability of nuclear material in the Central Asian republics, so also in the Eastern European nations, some of them, is there a possibility of an improvised nuclear device being made by somebody, some terror group, and being applied against us?
See, this is a common problem all over the world. Improvised and spreading radioactivity in a limited region by taking some nuclear waste or something and then detonating it in some place. Now, you can only seal your borders, which is being done when things move into our place. We have got in many places, certainly through ports and all that. If any radioactive material comes, one can stop it. This is the problem not only for India. It's true for anybody in the world. But you know, when we were discussing this in this expert group meeting in the International Atomic Energy Agency, we should not compare an radioactive IED with nuclear weapon. Obviously, you are not doing that. And he agreed with me, the US representative, that is comparing a firefly with a lightning strike, comparing IED with a nuclear weapon. But then,
that's perfect, sir. But the only issue is it can also cause large-scale destruction of lives, even if it is an improvised nuclear device. So, is there a mechanism we can devise to somehow, what's happening in Central Asian republics or in Eastern European region, the nuclear fissile material being available clandestinely? Can there be something done for that? I know it is.
All responsible countries in the world take care of their radioactive materials. All responsible countries in the world don't allow it to be they control it. Certainly, the materials which go for making the nuclear weapons, nuclear waste sites are very carefully monitored. But then, if somebody is not responsible, he allows this to be converted into this. You tell me what is the options. Suppose I bring a big 1,000-pounder general, 1,000-pounder inside, but it can cause a lot of damage depending on the structure you are eating.
Of course, yes, sir.
So there is no simple solution to this problem except control at the site where the thing is being produced. If your reactors is under safeguards, as in the non-nuclear weapon states, the International Atomic Energy takes care of make sure, because the nuclear waste also contains plutonium, for instance. So they take care of those materials. And most of the reactors in countries who are incapable of building reactors themselves, but they have imported reactors. There you find that it is under IAEA safeguards. But if they built it on their own, they are not under IAEA safeguards. And then it depends on their
Yeah. I think that's perfect, sir. Thank you very much for that. I just want to ask you one or two more questions. One is, there is a speculation that China, Russia, America, they may recommence testing. There's a speculation. Now, in that light, is there a reason for us also to revisit the self-imposed moratorium on our tests, and we also, somehow retest our thermonuclear devices?
You said use the correct word, speculation.
Yes, that's it. Exactly, sir.
And you want me to give a speculative answer? I don't give speculative answers.
So nice, sir. Thank you very much, sir. Sir, we have refrained so far from signing CTBT and NPT. Now there is a NWC treaty, which will, if adopted, which will, foreclose the use, possession, testing, shifting, and all sorts of restrictions it will put on the nuclear. It virtually would mean a nuclear disarmament. Also, it will allow international verification of your sites and everything else. I just want to know that, can this be carried on, or do we go for this? What is your view, sir?
Is there a verification clause there?
Yes, sir. There is a verification, independent international verification.
Not very clear. Not very clear. This is
Sir, there is a verification clause.
The Nuclear Weapon Convention was signed by how many? 22 countries?
Yes, sir. Yes, sir.
Signed. And it had to be ratified by 50 countries before it can come into. Of course, other important countries will ratify, that's a different issue. But only 38 countries have ratified it out of the last 3. When did it start? 2016. 2016. This weapon convention, to my mind, is not very different from nuclear disarmament. Nuclear disarmament is promised even in the NPT. How much has it progressed? Has any one of the ratified nuclear weapon states moved towards nuclear disarmament?
None.
So this we'll have to watch and see, because this is one more convention, and 3 years only 38 countries have ratified it. How much progress it will make? And then what about taking care of the steps which are promised against the NPT itself, as we in the old days? That itself will more or less do whatever.
Yeah.
Actually, it's a matter of mutual trust. mutual trust.
Sir, since you've been a very important and very critical part of IAEA on many occasions, and you were also a member of some citizens, some prominent citizens, which was dedicated by the DG of IAEA. Do you see a great role of IAEA in this nuclear disarmament?
See, actually, the disarmament issues. Hello.
Yes,
The
I can hear you.
Sorry, are you able to hear me?
Yes, sir. Yes, sir.
We are.
The disarmament issues are not discussed in Vienna. They are discussed in Geneva, where there is a separate body for disarmament. And here, IAEA's role, of course, they are promoting nuclear energy, no question about that. Peaceful users of nuclear energy, because it is very clear that if you are serious about climate change, as the International Panel on Climate Change has said, you have to go for low carbon technologies, which means renewables, nuclear, and hydro. Renewables, nuclear, and hydro, they are the technologies which are low carbon technologies. But then you must also remember that renewable energy, wind and solar are intermittent sources of energy. What do we do when the sun is not there? So it is very clear, and it has, if you read the recent statements on the future nuclear energy projections from IAEA or the world nuclear, I don't know, more than a dozen countries are going in for nuclear power in the beginning for the first time, including Bangladesh, Turkey, and so on. And if you do that, I think that is where the International Atomic Energy comes to their help. Essentially, they act as an intermediary between countries who have the capability to transfer knowledge and the people who are waiting to receive that knowledge. And of course, IAEA goes in a very big way to the promotion of applications of radioisotopes in a variety of fields. All that that is the role, and they of course do safeguards. If somebody buys a reactor from another country, that goes under what is called safeguards. IAEA inspectors are there at that reactor site to make sure that the spent fuel is not reprocessed and the resulting material is not taken out for making nuclear weapons. That's what we call safeguards, and they have done a very good job of doing.
One last thing, sir. You were to chart out the vision of the EA. Now I just want to know whether this agency is going to promote the peaceful, safe, and smart utilization of atomic energy, more importantly in the third world countries, or it is going to be restrictive?
Are going to?
Restrictive. I mean, will they promote this activity of utilization of nuclear energy for safe, secured, and peaceful application of the nuclear energy?
Absolutely, that is the part of their mandate, and they're trying to do that. They hold frequent meetings on, for example, what are the challenges for a new build reactors, people doing it for the first time. All those things, they hold meetings so that the people with experience can communicate. Safe nuclear energy, safety is one of their very big mandates, safety of nuclear reactors. And there are panels in which, of course, India is a member. And they had the panel called INPRO, Innovative Nuclear Reactors for Advanced Reactors, which are chaired by the former chairman Atomic Energy Commission, R.K. Sinhaji. So all these things they promote. Safe and nuclear energy is their mandate. to make sure that whatever the reactors, and there is a continuous, you learn from experience, and then you learn, and then transmit it to, apart from the regulatory boards which are there in each country, like big country like India, or the people who have a big nuclear program. Smaller countries may need assistance of regulatory bodies from more advanced countries.
So thank you very much, sir. And I really felt proud of that diagram when the intersection of the cutting edge technology with India and rest of the countries was fine. Thank you very much, sir. Really proud of you, sir.
Thank you very much. Thank you, kind of you.
I would request
That is
Dr. Padma, please.
Hello.
Yes.
Can you listen my voice?
Now I'm able to hear.
Yes, sir. नमस्ते सर.
Namaste, namaste.
आपका पेपर फिजिक्स का बहुत भारी था. हम सब कॉमर्स स्टूडेंट हैं और उसके पीछे माथुर साहब ने अच्छा खासा आर्सेनल ठोक दिया. वो हमारे कान के पास से निकल गया. अब थोड़ा से सर, मेरी जो पार्टिसिपेंट्स हैं, मैं इंडिया गोइंग नॉलेज इकोनॉमी, उसके बारे में मेरे कुछ सवाल जरूर हैं. आपकी स्पीच ने बहुत अच्छी तरह कवर कर लिया उनको, परंतु सर उसके पहले मेरे जो पार्टिसिपेंट हैं उन्होंने मुझे स्पेशली कहा सर कि कुछ एक्सपीरियंस आपके सुने, जैसे अटल बिहारी जी वाजपेयी ने जब 1998 का एक्सप्लोजन हुआ और आपका फर्स्ट कम्युनिकेशन हुआ या उसके पहले का कम्युनिकेशन हुआ, वो कैसा था, वो हम थोड़ा सा जानना चाहेंगे.
नहीं, मैंने एक इंटरव्यू दी है ये पल्लव बागला को, एयरपोर्ट के पास खड़ी हुई.
Yes, we have heard.
आप उसको देख सकते हैं. ये बड़ी खुशकिस्मती है कि उस वक्त वाजपेयी जी उधर प्रधानमंत्री बने, जो जिसके लिए हम 24 साल वेट कर रहे थे. 24 साल, 74 to 98. तैयार तो थे, कभी भी बोलो हम तैयार थे, और किसी ने हमें रोका नहीं इसके बारे में. इसमें बीआरसी में अनुसंधान करने के लिए किसी ने रोका नहीं. तो उन्होंने कहा, और हमने सोचा कि ये चांस मिला है, सब कुछ एक साथ कर दो, पांचों एक के बाद एक नहीं, तो 3 को एक साथ, 2 को एक साथ, 2 छोटू, इसमें से 3 छोटू थे. उसका ये ना, इसमें एक बात यह है कि एक क्रिटिकलिटी फैक्टर बोलते हैं न्यूक्लियर पार्लांस में, न्यूक्लियर की इसको K=1 मैंने कोई भी सिस्टम ले लो, इसमें न्यूट्रॉन की आबादी कितनी है इस जनरेशन में और न्यूट्रॉन की आबादी कितनी थी पिछले जनरेशन में, दोनों समान होंगे तो उसको K=1 कहते हैं. और साफ और सुरक्षित रखने के लिए जब आप इसको सिस्टम है, रिएक्टर है, क्या कि न्यूक्लियर वेपन पड़ा हुआ है, के 1 से छोटा है, कि सक्सेसिव जनरेशंस की जो न्यूट्रॉन पॉपुलेशन है वो कम होती जाती है, सुरक्षित रहती है. जब इसको एक साथ लाते हैं, डेंसिटी को चेंज करते हैं और एक दूसरों को पास लाते हैं, तो के ऊपर हो जाता है. ये न्यूक्लियर वेपन में यही करते, फिशन वेपन में. और जब ऊपर चढ़ के मैक्सिमम हो जाता है तो उस वक्त दिया सिलाई लगा दो, न्यूट्रॉन सोर्स रिलीज कर दो और न्यूक्लियर रिलीज होना शुरू होगा. और जब वो एक्सपैंड होता है, जब तक वो के 1 से कम नहीं होगा, वो एनर्जी रिलीज करता रहेगा. और इसको पकड़ के रखने के लिए इसको टेम्पर वगैरह लगाना पड़ता है. ये है फिशन रिलीज. ये तो रिएक्टर में भी ऐसा ही होता है. जब रहता है तो उसके कंट्रोल रॉड अंदर जाते हैं, तो इसको K<1 में बिठा देता है. धीरे से ऊपर खींचते हैं. जब के उससे छोटा थोड़ा ऊपर हो जाएगा, इसमें मैं ज्यादा टेक्निकी शब्द नहीं करूंगा. डिलेड न्यूट्रॉन्स भी हैं जिसको और सुरक्षित बनाते हैं. जो पावर चढ़ना हो जाएगा और फिर उसको वापस लाके, जब एक रिएक्टर है वो 20 वाट में काम करे या 200 मेगावाट में या 700 मेगावाट में के करीब 1 के करीब होता है, के इज इक्वल टू 1। पावर ज्यादा करना है तो के थोड़ा ऊपर चढ़ाएगा फिर नीचे कर देने।
सर क्या ये सारी स्टोरी आपने अटल बिहारी जी को सारा ब्रीफ कर दिया था, ये छोटू मोटू का किस्सा?
हाँ जी,
जो छोटू मोटू का किस्सा बता रहे हो, छोटू मोटू?
नहीं, उनको पूरी जानकारी थी और वहाँ ब्रजेश मिश्रा जी भी थे उनके साथ
जी।
तो उनको हमने पूरी तरह से ब्रीफ किया था कि ये सब करने वाले हैं। उन्होंने कहा जो कुछ चाहो करो।
अच्छा, वंडरफुल। एंड व्हाट वाज आफ्टर द एक्सप्लोजन व्हेन यू स्पोक टू हिम फर्स्ट?
एक्सप्लोजन में वो तो बहुत बड़े खुश थे। उन्होंने अनाउंसमेंट तो उन्होंने इमीडिएट कर दिया था। जब हम लोग पोखरान में थे तो उनका अनाउंसमेंट तो उसमें आ गया था। फिर जाके हम मिले उनके साथ।
It must have been very memorable, sir.
वेरी मेमोरेबल, एब्सोल्युटली।
Big achievement of yours.
इस मौके के इंतजार में थे हम कितने साल, मैंने कहा 24 साल। और थोड़ी देर इसी ऐसी बात है कि जो न्यूक्लियर ऑप्शन ओपन की बात है ना, ये बहुत दिन इसको ओपन नहीं रखा जा सकता।
जी जी।
जैसे जवान आदमी है, मैरिज ऑप्शन ओपन बहुत दिन एक दिन आ जाएगा उसका मैरिज ऑप्शन अपने आप क्लोज हो जाएगा। तो मेरे अमेरिकी दोस्तों ने बताया था कि हम वेट कर रहे थे कि आप लोग रिटायर हो जाएंगे तो ऑप्शन एक्सरसाइज कैसे करेंगे। इसीलिए मैं कहता हूँ खुद किस्मत ये बात है, वाजपेयी है आ गए। अभी तो हमने अपना काम जो था वो कर।
जी सर, एक 74 और 98 98 दोनों एक्सप्लोजन के बारे में इतनी जो दोनों एक्सप्लोजन्स किया आपने 1974 और 1978, the world was surprised. They didn't have a small idea about this program. What was the how could you manage this much of secrecy?
See, 98 में ऐसा होता है कि इनकी जो ऊपर से स्पाइस सैटेलाइट्स जो जाते हैं ना,
जी सर,
ये जो साइट जो है, ये साइट जो है छेद तो खुला हुआ है, इसको देखेंगे तो प्रिपरेशंस को पता चल जाएगा। तो बड़े उसके ऊपर कैमोफ्लेज टेंट लगाया हुआ था कि पहली चीज तो ये थी कि किसी को पता नहीं चले। और हमारे जो आर्म्ड फोर्सेस थे उन्होंने बहुत बढ़िया काम किया। जो कर्नल जो थे बंगाल इंजीनियरिंग रेजिमेंट, कर्नल कौशिक जो थे उधर बंगाल इंजीनियरिंग रेजिमेंट में 3 साल में एक बार उधर रेजिमेंट बदलता आया है। ये हो रहा है 20 साल से, 98 से पहले से भी वो होते थे। और बाकी सब सादा काम कुछ करते थे कि ऐसे तो नॉर्मल ऑपरेशन है। और मूवमेंट जो था अपने लोगों का या टक्स का उस वक्त होता था जब स्पाइस सैटेलाइट नहीं थे, और उनको आने जाने का तो इसरो हमें फोन में बता देता था कि ये सैटेलाइट, हमें तो मालूम है कि कौन से स्पाइस सैटेलाइट है। लेकिन मैंने वाजपेयी जी से कहा था कि लास्ट 2 दिन जो है मुझे कब हमें कैमोफ्लेज टेंट निकालना पड़ेगा, वो तो गैपिंग होल है और उनको तो दिखेगा। तो वाजपेयी जी ने कहा वो पॉलिटिकल वो हम संभाल लेंगे, आप उसके बारे में चिंता मत कीजिए। लेकिन ऐसा हुआ कि वो सैटरडे संडे था, जो हमने मंडे टेस्ट किया 2 दिन पहले सैटरडे संडे था। तो शायद ऐसे ही कुछ लोग अपने एंजॉय कर रहे थे, देखा नहीं उन्होंने। ये तो I'm just making a joke out of it.
No,
But the fact is they missed it.
it was really very excitement all across the country at that time, and when there were movement of people or military trucks, as you said, but suppose from Jodhpur to Pokhran or coming from Badmer to Jaisalmer, how this coordinated operation was organized?
ये बात है कि 1970 के बाद
जी सर,
1999 तक
जी,
हम आते थे प्लेन में जोधपुर तक, रोड में जाते थे पोखरान को। तो ये तो मैं कहता हूँ पहला हमारा होम स्टेट है तमिलनाडु, दूसरा होम स्टेट है महाराष्ट्र जहाँ पूरी प्रोफेशनल लाइफ हमने गुजारी है, और हमारा तीसरा होम स्टेट है राजस्थान। यहाँ इतना टाइम गुजारा है, इतना टाइम गुजारा है यहाँ से वहां जाते वक्त, कभी कभी जैसलमेर से भी आते थे। और ये तो रेगुलर आर्मी के मेस में ठहरते थे, वहां के रेजिमेंट के लोग हमें ले जाते थे, नॉर्मल मूवमेंट किसी को पता नहीं चला। और जैसे अरोरा जी कह रहे थे, हमारा नाम रखा था जनरल नटराज, राम जी का नाम रखा था जनरल पृथ्वीराज। क्यों रखा था मालूम है नटराज? कि चिदम्बरम में सबसे बड़ा मंदिर है नटराज का, नटराज का टेम्पल है, इसलिए हमारा नाम नटराज रखा। मैं चिदम्बरम का नहीं हूँ, हम तो दूसरे तंजौर डिस्ट्रिक्ट के हैं। हमें 60 साल के बाद हमें पहली बार चिदम्बरम गए थे, लेकिन मशहूर इसीलिए उनका नाम। हाँ भंडारी जी।
यस सर, वेरी ब्रीफली उसमें थोड़ी और बातें पूछेंगे कभी आपको, और सुनेंगे कि आपको इसी ड्रेस में ले जाते थे मिलिट्री वाले, या कुछ आपको और कपड़े पहनाते थे आपका?
नहीं, ये तो बहुत बढ़िया चीज थी, वो तो बड़े दोस्त थे। यानी सबसे बड़ी बात यह है कि इतने आर्मी लोग हैं जिन्होंने ये जो होल था उसको डिग करना भी इंजीनियरिंग रेजिमेंट्स ने किया, और इतनी डीप जाते हैं तो पानी तो आता रहता है, और उसको निकालना भी आर्मी के लोगों ने किया। और ऑफ कोर्स नॉन कमीशन ऑफिसर्स भी, नॉन कमीशन पीपल भी थे, जवान थे। और ये बड़ी बात है कि इतने लोगों को कैंप में रहने के बावजूद ये खबर किसी तक नहीं पहुंची कि हम टेस्ट करने वाले हैं। वैज्ञानिक तो थे, ये सब करते थे, लेकिन आर्मी ने जितना मदद किया उसको भी आपको ध्यान में रखना चाहिए। और ये 3 साल में एक बार बदलता जाता था।
74 के एक्सप्लोजन के बाद आपने जब प्राइम मिनिस्टर को ये सूचना दी या उनको मालूम पड़ा, तो उन्होंने भी बधाई और खुशी जाहिर करी होगी सर?
बिल्कुल बिल्कुल, वो तो बहुत खुश थे, तो बड़े खुश थे।
It must be great honor, sir. Yes, sir. Well, first I cannot stop explaining that all my colleagues and participants are very delighted to have you. You are an institution in yourself and a national asset. Your eventual long journey of more than 60 years since you started teaching in Madras University in 1958 is a matter of pride. The journey has been unabated and laying many milestones. Your long stint of more than 15 years as principal scientific advisor to Government of India and 7 years as chairman of Atomic Energy Commission with different regimes and prime minister speaks of large volume of your independence, intellectual depth, and missionary spirit. JCF will look forward for continued dialogue and hear many untold stories for our benefit. Sir, I have two small questions asking in relation to the India going next stage of economy. Your speech and message has been loud and clear, and India to become knowledge economy. Sir, India is the only fortunate country with billion biometrics, billion mobiles and billion bank accounts, nearly billion bank accounts, and which will help us greatly to take it forward. I'll go very fast asking you some small questions. Sir, you mentioned dream of India where human development index has to be high. With wide disparities and poor access to quality education, how can India become a leader in creating a knowledge-based economy? How education system can be changed in Indian environments to meet the challenge?
See, Human Development Index, let me tell first. Human Development Index is defined by the United Nations in terms of 3 parameters: per capita income, life expectancy at birth, and they used to use adult literacy. Nowadays they are using the level of education. For 20 years and more I have been saying, and I have shown it actually in written articles, that it can be defined for a country like India in terms of just two parameters. Per capita electricity consumption, because as you know, electricity is the most convenient form of energy, and female literacy. I prefer female literacy to adult literacy because it's a measure not only of literacy, but of equity and justice in that society.
Great.
You find that any part of India where the average literacy is low, the difference between male literacy and female literacy is high. But that is a part of lack of social justice in that society. But it is a fact, it is very well known, I've written about it, that if you plot infant mortality against female literacy, there is a very strong correlation. The higher the female literacy, the lower is the infant mortality. The higher is the female literacy, the lower is the birth rate. And of course, per capita electricity consumption. Of course, India is growing, no question India is growing. But the per capita electricity consumption has to go up by at least 6 to 8 times before India can become a developed country in the fullest sense of the term. That's why all energy options are important for India. But at the same time, we must remember that we must take care of climate change. Make sure that we reduce carbon emitting technologies when we produce power to the extent possible. For next 20, 30 years, you have to burn coal. There's no question about it. Place like India. In fact, our per capita carbon dioxide footprint is very low compared to the developed countries. Maybe 1/10 or even less per capita. See, the problem is India is such a large country. Anything per capita, good or bad, you multiply by the population of India, looks large. That's why when I used to attend these conferences on climate change, which the US had called, I said the right parameters per capita, not the total. Total limiting, naturally we are a big country. If you take tiny European states, they look very small. And that is why all energy options, and next 20, 30 years, we have to burn coal. But here, that is why I started this project called Advanced Ultra Supercritical Thermal Plant, which 2016, the cabinet has approved a 1,500 crore grant. If you are able to increase the temperature of the steam, for the same power you emit less carbon dioxide. There's a question of efficiency of that. And that is what we have done. That I showed one of the slides, you may not remember. We brought Indira Gandhi Center for Atomic Research, BHEL, and NTPC together. It is actually funded to the Ministry of Heavy Industry, and it is going on there. And of course, we have to encourage research, which is happening. And we have very good scientists. And of course, sometimes the scientists have come into prominence only during the COVID time. Everybody is here listening to what we are doing in terms of the vaccine development, in terms of the testing, what new tests Shri is doing, or vaccine development here and there, and the way we are respected internationally. Did I answer your question?
It was great. Yes, it's almost because we didn't know that we are already developing. In 2016, you took a project for relation to power, but it's a very great.
See, many of these things in the beginning, of course, we didn't have. Now, most of the things are now made in India, and of course, vaccine development will take 1 year at least. Normal vaccine takes more than that all over the world, not only in India, because one has to go through clinical trials.
My next question is the impact of advancement of artificial intelligence on the future work, maybe having ripple effect on widening inequality and job losses. How do you think so?
See, the same thing was said when computers were brought in by Rajiv Gandhi.
Yeah, absolutely.
That there will be
absolutely.
losses. I think new kinds of jobs will be created. There are two kinds of things. Only robotics you have to be careful about. Make sure robotics will the cost lower. Artificial intelligence has got many aspects. See, if you analyze data relating to any area, I gave an example of nuclear, but you take any field. See, when you take a decision, you based on experience and of course intuition to some extent, you analyze all the available data and then you take the decision. The doctors, when they do a diagnosis, one can see that artificial intelligence can be very useful. For instance, somebody in the US, MIT, they did an experiment. Vocal cord disorders. They put an accelerometer in the neck and took the vocal cord signals of a large number of patients and created the database. And from database, they can make out that for a new patient, does this guy have a vocal cord disorder or not? Of course, final decision you can't in the case of a medical. AI is coming very big in the medical field. So there it is only an assistive to that. Finally, same thing, robotics. You can do robotics, remote surgery you can do, but the operation is done by the doctor here. Master slave manipulator, when we are handling radioactive materials, we didn't call it machine learning at that time, but we are doing it for a very long time. See, if I may, how much time have you got? I can go on and on.
Two, three small questions.
Yeah.
Yeah. Why we have not been able to harness solar energy despite of new technology and cost of the equipment and raw material having gone down?
See, you cannot say we are not harnessing solar energy. Just now, I read somewhere Adani Green Energy has got the world's largest solar energy order. I think that's going to cover Rajasthan and Gujarat. But the problem is we have to do the full supply chain. Solar cells we are still importing. See, the Prime Minister's plan for a self-reliant India must, of course, they are going to look at every technology. You must make the polysilicon from the quartz in the sands. From the polysilicon, you must make silicon, pure silicon crystals, cut the wafers, make the solar cells. All this technology is there. But then those who have got into the field early have brought down the, of course, we make solar energy, but we are dependent on the solar energy is a growing field. There's no question about it. But then we have to also combine it with storage. Because at a time when either you put for the extra energy, this power you supply through nuclear or hydro or some such power or coal, but the fluctuating part you can do that, or you must adjust it according to the plant load maximum. You can do rooftop solar, you can do industrial solar. This is the answer to remote regions. Solar energy, where you are not able to transmit power, solar is the answer. And the cost of transmission, instead of which you do the cost of storage, it is growing, but then we have to do the complete supply chain also. But there's no question solar is growing. As you know, there is an International Solar Alliance whose headquarters is in Gurgaon. What is it called now? Gurugram. Gurugram.
Sir, my next question is a very small one, which you during our discussion also mentioned. One of India's main concern is around the huge waste, be it industrial mining, rural garbage, or other disposables, which is leading to health, hygiene, and pollution issues. How can we develop technology like waste to energy or waste to fertilizer in an environmental friendly manner? Is India working for recycling by technological innovation and monitoring? Your observation, sir?
Bhandari-ji, in your society, housing society, do you separate wet garbage and dry garbage? Kitchen waste was in dry garbage. Because it's the wet garbage which can be converted into fertilizers. Yeah, PRC has a project called Nisarguna. Nisarguna is very converting it into biogas. And this technology under ROOTAG, which I mentioned, you also mentioned in your letter, ROOTAG. Under ROOTAG, we have taken it to Tripura also. ROOTAG, we are trying to push these technologies. So it is beginning to happen, but surely. But it's not only domestic waste. My friend Captain Mohan Ram was very keen on recycling auto waste. Auto waste, of course, you say pollution, you junk your car. But where do you junk it? Junkyard. And if you do that, or in some of these places, the old cars lie around and the urchins or their whoever are their mentors take away the useful parts, and that remains as an eyesore. But if you take auto waste, Captain Mohan Rao told me if you take the aluminium from auto waste by 2020, by now, that is now, there will be 180,000 tons of aluminium in that waste, which can be recovered at 6 to 7% of the energy you spend on smelting aluminium ore. And like that for rubber, obviously steel. And there are varieties of plastics there. And some of these, auto waste thing we supported from our office. And also now people are concerned about electronic waste, some of which is toxic. Concern is there, but it's not only in India, it's all over the world. And in fact, now we had pushed auto waste. I think if I remember right, the Environment Ministry has issued an order that when you build a car, you must also have a program for recycling the auto components. Where you can fix it, don't weld it. So removal become easier. So it's a complex problem which we have to look at sector by sector. But at least all of us should separate dry garbage and wet garbage anyway. In our society, we do that. My wife is a champion of that.
Yes.
Garbage in our society.
The last question is, sir, that which I should have taken earlier. Agriculture being the most important area of our economy to improve farmers' income needs to be agriculture sector.
Agriculture, yes.
We need to expand aggressively to support the vision of India become knowledge economy. How technology is helping in this direction?
See, obviously one has to give them new varieties of seeds, which they are doing. The Department of Agriculture is doing that. We should not fight shy of genetically modified crops. After, of course, taking due diligence of their safety. My friend Professor Deepak Pintal in Delhi University, formerly Delhi University, make GM mustard, excellent, higher productivity, and then it can replace all the mustard, and then income can go up. Farmers associations want it. But there are some people who are, of course, we must be careful, there's no question about it. All these biosafety trials, have they been done? The committee approves it. That is one method. That's not the only method of doing it. Then technologies of a variety of kinds in terms of make sure the soil carbon doesn't go down by pollution doesn't happen by overuse of water, conserve water, drip irrigation. Because you have your waterman, Mr. Rajendra Singh in Rajasthan, who has done excellent work in this area of water conservation and water reuse. But we must make sure sometimes increased productivity by the farmer does not result in increased income for the farmer. If he overproduces, the prices in fact come down, income goes less. So it's a very careful, you must have good storage of these things. Don't allow surpluses to enter the market. If there is overproduction, put it away. You have to improve the storage side. Sometimes it has to be cryo storage if it is perishables, not for a long period, but for a period. Cryo transport. My friend, my Department of Atomic Energy, Raja Ramana Center for Advanced Technology, used a new cryo transport system.
What is that, sir?
Cryo transport. That is, you transport perishables from one market to another, from a market where the prices have crashed to a neighboring market where the prices are high. If you're able to move, the farmer gets more income. But then it has to be done in a cyclic manner, so that from A to B you move something which is needed in B. From B to C you move something which is needed in C. And then back to A where something which is needed in A. And he has a new technology using liquid nitrogen, because all our cryo transport system use diesel oil and imported cryo machinery. And now this is progressing well. This is progressing well. So you see, the improving the agricultural system is a complex system. Both Department of Agriculture, marketing, there is economics, and financing of the people. Apart from you have to give subsidies at a critical period of time. But we want to have proud farmers who will be able to decide what they want. And other technologies, improved machinery, which we have also done to some extent under RUTAG, and not only under RUTAG, so many other people they have done it for smaller things.
सर, आपको धन्यवाद देने से पहले मेरे कुछ पार्टिसिपेंट्स हैं, वो कुछ क्वेरीज आपसे करना चाहेंगे. 10 मिनट का समय मैं और मांगूंगा आपसे. आई हैंड ओवर माइक टू जाजू जी.
So just a minute, sir. So there's a question from Mr. Rahul Manot. Having described various technologies and area of advancement, why so far we have not been able to prioritize area which you narrated, like economic development or scientific advancement and strengthening military security? And results are visible that we, even after 70 years, not able to claim unique leader in any of these areas. Do you feel our policymakers need a debate and assign priorities in order to become leader in one or two of this? Is not correct? Will you share one or two such?
See, this is economically developed, scientifically advanced, militarily strong are generic phrases. India is advancing. India is advancing. Literary levels have gone up, no question about it. Per capita electricity consumption has gone up. But you know, from the base level that we started to reach because of the colonization and other problems, and of course we want to be a democratic system. We don't want an autocratic system in which orders are issued from somewhere and we meekly obey. Growth can be accelerated, but Indians by culture, they want freedom. They want a democratic system. There are very good scientists who have, even now they are contributing to any area that you take, one can think of good scientists. But this is a process which will take some time. Of course, we have a setback because of this COVID business. So you see, the per capita income goes up by percentage. You can't say I will double your income next year. Just doesn't happen. It has to grow by
and that
percentage.
such a large
You
population.
can double the income of people near the poverty line. People near the poverty line, and they will benefit very greatly. That is the first thing that we should do. I think Prime Minister Modi has mentioned it in the context of marginal farmers. And I've always said, person is near the poverty line, then his quality of life is a very non-linear function of his income. Suppose he's earning 100 rupees, 90 rupees goes on survival. 10 rupees is dependent, his quality of life is dependent on that. Suppose I double his income, his quality of life goes up by 1 order of magnitude. Suppose you double my income or Bhandari ji's or Arora ji's, nothing will change in our quality of life. Of course, our bank balance will go up.
Yes, sir.
So first we should take care of our people who are near the poverty line, including marginal farmers. Question Bhandari ji asked. First, the marginal farmers. That's the one. Of course, we have had the green revolution. Not that we have done nothing.
Here done.
Revolution. Remember, at one time we were dependent on wheat aid from the US.
Yeah,
Colleagues have done a wonderful job on the green revolution. We are self-sufficient in food. These are all great achievements. We cannot. Yes, go ahead.
So the best part is of any topic, on any topic, you are extraordinary. Means I think
Without it.
you replied on each and every question. People are so happy. So sir, thank you very much for blessing people of Jaipur, Jaipur Citizen Forum, and our guests from all over the world on webinar and on Facebook. We are really fortunate that we got an opportunity to see you, to listen you, and your past experiences and present position India holds. Sir, it was amazing. It will be remembered for a long, long time. It was a lifetime experience for all of us. Sir, हम गर्व से कह सकते हैं कि आज हम भाग्यशाली हैं कि हमने उस शानदार व्यक्तित्व से मिले हैं और शानदार व्यक्तित्व को सुना है जिसने भारत का सिर पूरे विश्व में गर्व से ऊंचा कर दिया था. So sir, thank you so much for important time for us.
And I thank you very much. Thank you very much. It was a pleasure to talk to Jaipur citizens. Of course, I visited Jaipur. Your town is a beautiful town. I have come to your NIT, their MNIT in Jaipur. Jaipur, of course, I have taken around. Also Udaipur. It's wonderful. Udaipur is.
आप वापस आइए जयपुर. डॉक्टर चिदम्बरम आप जयपुर आइए. राजस्थानी खाना खाए बहुत दिन हो गए होंगे आपको. तो हमारे से हम मौका देंगे. हमारे पूरे मेंबर्स के संग आपको खाने में बुलाएंगे.
मैं एक बार और बताता था. एक बात और बताता हूँ. हमारे जो पहले इंडिजिनस रिएक्टर थे वो कोटा के पास वो रावत भाटा है ना. रावत भाटा में है. वहीं से हमारी indigenization of pressurized heavy water reactor started. The first reactors came from Canada and then the indigenization started from there only.
So it was, I think, long back in 60s, early 60s it was.
Early 60s. 60 के बाद हुआ. 69 में तारापुर आया.
जी.
मैं हिस्ट्री में वीक हूँ थोड़ा.
Your memory is fantastic, sir.
Very good. Thank you very much, sir.
Thank you and all the best to you.
Thanks to Major General Anuj Mathur and
Thank you very much.
So आप लोगों ने इतना बढ़िया क्वेश्चन आंसर का एक समा बांध दिया कि सबको मजा आ गया. So thank you so much, sir.
Thank you.
Blessed to your blessing, sir. Thank you so very much.
Jai Hind.
God bless.
Thank you, sir. Jai Hind. Jai Hind. Jai Hind.